The power of generative AI is transforming the way we approach tasks from simple text generation to complex decision-making. Today, we're exploring the evolutionary journey of AI architectures through four distinct paradigms, each building upon the previous to create increasingly powerful and practical AI solutions. Our presentation today will focus on the evolution of AI architectures, from simple LLMs to sophisticated agentic systems, and we'll start with the foundation, the large language model. The large language model represents our starting point, a powerful yet straightforward approach to AI text generation. At its core, an LLM operates on next token prediction, processing user input through a rules-based trigger system and producing output directly without external data retrieval. The workflow is elegantly simple: user input, rules-based trigger, large language model, output. The LLM relies entirely on its training data, functioning as a self-contained system that generates responses based on patterns learned during training. Strengths and applications: lightning fast with low complexity and easy deployment, LLMs excel in speed, simplicity perfect for straightforward text generation tasks. Ideal use cases include chatbots, email drafting, basic content creation, and simple Q&A scenarios. Limitations: the simplicity comes with trade-offs. LLMs suffer from limited context understanding and cannot access real-time information or integrate new data sources beyond their training cutoff. And that brings us to the revolutionary capabilities of the RAG. Retrieval Augmented Generation addresses the fundamental limitation of static LLMs by introducing dynamic knowledge retrieval. This architecture transforms the AI from a closed system to one that can access and utilize external information sources. And here's the architectural components: the embedding layer, the vector database, the retrieval system, and the augmentation process, which powers a user query, embedding, vector database retrieval, data plus system prompt and user prompt to augmented generation and an output. Revolutionary capabilities include smart knowledge retrieval, accessing multiple data sources in real time, enhanced accuracy, grounding responses in factual, up-to-date information, and domain expertise, excelling in specialized Q&A scenarios. Considerations are that RAG systems are highly sensitive to data quality and structure. The famous principle garbage in, garbage out applies critically here. The system's effectiveness correlates with the quality of its knowledge base, and that brings us to level 3. AI agent, autonomous intelligence. The paradigm shift: AI agents represent a fundamental leap from reactive systems to proactive autonomous entities. These systems don't just generate responses. They plan, reason, remember, and execute complex workflows independently. Core components include the system prompt and the user prompt, which define the agent's role and current task, a database integration, which accesses persistent information, feedback loops, which learns from interactions and outcomes, a planning module that develops step-by-step strategies, a memory system that maintains context across interactions, a reasoning engine that makes decisions based on available information, and tool integration, which utilizes external tools and APIs. Autonomous capabilities: unlike previous architectures, AI agents can plan multi-step workflows, make independent decisions based on context, learn and adapt, and tool utilization. Best applications are for research assistance requiring multiple steps and sources, data processing workflows with decision points, task automation requiring reasoning and adaptation, and single-user productivity enhancement. Requirements for success: AI agents need well-defined goals and reliable tool access to function effectively. They excel in structured environments where objectives are clear and measurable. And that brings us to level 4, Agentic AI, collaborative intelligence. Agentic AI represents the pinnacle of current AI architectural thinking. A multi-agent ecosystem or specialized AI entities collaborate, coordinate, and even negotiate to solve complex problems that no single agent could handle alone. And here's a multi-agent architecture with specialized agents, shared components, coordination layer, tools and database, and sensory data integration. Collaborative capabilities include work division, knowledge sharing, collective problem solving, adaptive coordination, and persistent memory. Enterprise applications are for large-scale project management, complex problem solving and research and development, multi-departmental workflow automation, and strategic planning and execution across organizations. Advanced features include flexible task distribution, specialized expertise, and scalable collaboration. With that will bring us us to our comparative analysis, choosing the right architecture. We'll look at functionality spectrum, use case optimization, strengths analysis, and the limitations to consider. And as we see with real-world examples and applications, LLM applications would be simple chatbots, email drafting, basic content creation. RAG implementations, advanced customer support systems, knowledge management platforms, and research assistants that need access to current information. AI agent solutions include React and Rewoo agents that can perform complex research tasks, data analysis workflows, and automated report generation. Agentic AI systems include enterprise solutions like customer understanding assistants and embedded multi-agent systems that handle complex business processes requiring coordination between different specialized functions. And that brings us to the strategic decision framework. When choosing between these architectures, consider the complexity of task, data requirements, autonomy needs, scale and collaboration, and resource investment. Future implications and trends, we're seeing hybrid approaches, industry specialization, enhanced integration, and improved coordination. In conclusion, the practical path forward. The evolution from LLMs to agentic AI represents more than technological advancement. It's a transformation in how we approach problem solving with AI. Each architecture serves specific needs. Start with LLMs for simple, fast text generation, upgrade to RAG when you need current and accurate information, implement AI agents for autonomous task execution, and deploy agentic AI for complex collaborative problem solving. The key insight is that these aren't competing technologies, they're complementary tools in an increasingly sophisticated AI toolkit. The most successful AI implementations will thoughtfully combine these approaches, matching architectural complexity to problem requirements while maintaining practical feasibility. As AI systems become more intelligent and capable, the progression from simple text generation to collaborative intelligence represents our journey towards truly practical AI that can handle the complexity of real-world business challenges. The future lies not in choosing one architecture, but in orchestrating them effectively to create AI solutions that are both powerful and purposeful.